In this video, we will see AC fundamentals, introduction, comparison between alternating current and direct current, basic concepts, what is waveform, what are the types of waveform, then we will see what is frequency, then what is time period, then what is amplitude, then what is RMS value or root mean square value, what is average value, what is impedance, what are the components and circuits. Then we will see power in AC circuit. We will see real power, reactive power and apparent power and power factor. If you want to buy notes, then check the link in the comment section and install the app now. Also, don't forget to subscribe to this channel. Introduction. Now here we can see this is the waveform for alternating current. On x-axis, this is time, and on y-axis, this is magnitude. Alternating current changes its magnitude and direction with respect to time. Now here for direct current, on x-axis again this is time and on y-axis this is magnitude. For direct current, it do not change its magnitude or direction with respect to time. Direct current have a constant magnitude. Here we can see it is a straight line. Now what are waveforms? So there are various types of waveforms. Sine wave, the most common AC waveform. Sine wave is the most common type of waveform. Here we can see this is called as sine wave. It is characterized by its smooth periodic oscillation. So here we can see it have a smooth periodic oscillations. So this is how a sine wave looks like. Then next is square wave. Square wave used in digital and switching circuits. So this is how a square wave looks like. It looks like a square, that's why it is called as square wave. Then next is triangular and sawtooth wave, used in some signal processing and audio applications. So since it looks like a triangle, that's why it is called as triangular wave. This is the triangular wave. Then next is sawtooth waveform. Here we can see it looks like a sawtooth, that's why it is called as sawtooth waveform. Next is frequency. Now remember that frequency is represented by small f, the number of cycles per second measured in hertz. So first of all, what is frequency? So frequency is the number of cycles completed in 1 second. Now what is cycle? Now here we can see these are the cycles. So from here to here it is one complete cycle, one positive phase and one negative phase. So it is called as one complete cycle from this 0 to this mark. It is called as one cycle. Again this cycle is repeating again and again. So it is called as cycle. So how many cycles completed in 1 second? It is called as frequency and it is measured in hertz, which is represented by Hz. Common frequencies are 50 Hz and 60 Hz. These are the frequency which we use in our homes. Different countries have different frequencies depending on the country, but most of the countries have 50 Hz frequency. The number of cycles completed by an alternating quantity in 1 second is called frequency. It is denoted by small f. Unit of frequency is cycles per second or hertz. Generally, the unit of frequency is hertz, which is represented by Hz. Also remember that frequency is the reciprocal of time period, or we can say frequency is equal to 1 upon time period. Time period is represented by capital T and it is measured in second. Now here, let's see, for this waveform, from here to here, this time period is 1 second. Now let's see how many cycles completed in 1 second. So let's count: 1 cycle, second cycle, third cycle, fourth cycle, fifth cycle, and then sixth cycle. So here, for this there are total 6 cycles completed in 1 second. That means the frequency of this waveform is 6 Hz. Now for this waveform, from here to here, this is 1 cycle. Then from here to here, this is second cycle. From here to here, this is third cycle. So in 1 second, total 3 cycles completed. That means the frequency of this waveform is 3 Hz. Then next is time period or period. It is represented by capital T. The time it takes to complete 1 cycle of the wave is called period. Now here, from here to here, how much time it takes to complete 1 cycle? It is called as time period. How much time it takes to complete 1 cycle? It is called as time period. It is denoted by capital T. Unit of time period is second. So remember that the unit of time period is second. Now what is amplitude? Amplitude is the maximum or peak value of an AC quantity is called amplitude. Now here we can see, for this waveform, on positive side this is the peak value or maximum value. On this side, this is the maximum or peak value. So this is also amplitude and this is also amplitude. For voltage, amplitude is represented by Vm, maximum value of voltage, or we can say maximum or peak value of voltage, or we can say amplitude of voltage. For current, if this is a current waveform, then the amplitude is represented by Im, maximum value of current or peak value of current. Then next is root mean square or RMS value. Now what is RMS value? A measure of the effective value of AC voltage or current. So it is the effective value of voltage or current. For a sine wave, it is given by Vrms is equal to V peak divided by root 2. Now what is V peak? We have already seen that this amplitude is, it may be Vm. We can also write V peak or we can write Vm. So both are correct. Here we can write Vm divided by root 2. Now we already know what is Vm. So Vrms is equal to Vm divided by root 2. Then we get the value of RMS. Then next is average value. Now average value is the average value of an AC waveform over one complete cycle is the arithmetic mean of all instantaneous values of the waveform. So we will see this. These are the instantaneous values. So if we take average of these values, or we take arithmetic mean of all instantaneous values of the waveform, then we get the average value. So it is given by 2 by pi into V peak, or we can write 2 by pi into Vm. So Vm or V peak, we can write any of these. So this is about average value. Then next is impedance. Impedance is given by capital Z. It is represented by capital Z. The total opposition to current flow in an AC circuit is called as impedance. The total opposition to current flow in an AC circuit combining resistance, inductive reactance and capacitive reactance, it is called as impedance. Now here inductive reactance is represented by XL, where this L represent inductive and this X represent reactance. For capacitive reactance, this C represents capacitive and this X represent reactance, and resistance is represented by capital R. So it is the opposition to the flow of alternating current. It is called as impedance. Now components and circuits. So resistor is represented by R. It opposes the flow of current. In AC, the voltage and current are in phase. So remember that this is the symbol for resistor. Now for AC, both voltages and current are in phase. So like this, we will see this in detail. So both are in phase. Remember that for resistor, both voltage and current are in phase. For inductor opposes changes in current, or we can say sudden change in current. Inductor opposes sudden change in current, and capacitor opposes sudden change in voltage. Inductor is represented by L, capacitor is represented by C. Now inductor, in AC the current lags the voltage by 90 degree. So for inductor, current lags, and for capacitor, current leads. In AC, the current leads the voltage by 90 degree. So these are the resistor, inductor and capacitor. Now what is reactance? So reactance is represented by X. Now there are two types of reactance. One is inductive reactance and second is capacitive reactance. Inductive reactance is represented by XL. So XL is equal to 2 pi FL. XL is equal to 2 pi into F into L, where F is the frequency in Hertz and L is the inductance in Henry. So this is inductive reactance, and capacitive reactance is represented by XC. It is equal to 1 upon 2 pi FC, where this C is the capacitance in farad. Also remember that the unit of inductive reactance is ohm, and the unit of capacitive reactance is also ohm. Then impedance in series circuits. So impedance in series circuit is given by Z is equal to under root of R square plus XL minus XC. So Z is equal to R square plus XL minus XC. This is for series circuit. And for parallel circuit, it is given by 1 upon Z is equal to under root of 1 upon R whole square plus in bracket 1 upon XL minus 1 upon XC whole square. So these are the two formula for calculating impedance in series and for calculating impedance in parallel. Then next, power in AC circuits. Real power which is represented by capital P. It is the actual power consumed by the circuit measured in watts. It is represented by capital W. So power formula is power P is equal to Vrms into Irms into cos phi. Root mean square. This RMS represent root mean square value of voltage into root mean square value of current into cos phi. Now what is RMS value? Vm divided by root 2. If we solve Vm by root 2, then we get the value of Vrms. Again, if we solve Im by root 2, then we get the value of Irms. And this cos phi is the power factor, where phi is the phase angle. Then next is reactive power. Reactive power is represented by Q. The power stored and released by inductors and capacitors measured in volt amperes. Volt ampere reactive. So remember that the unit of real power is watt and the unit of reactive power is volt ampere reactive. The formula to calculate reactive power is Q is equal to Vrms into Irms into sin phi. Now here for real power we write cos phi, and for reactive power we write sin phi. Also remember that reactive power is represented by Q. Then next is apparent power. Apparent power is represented by capital S. It is the combination of real and reactive power. It is measured in volt ampere, in short VA. Again, apparent power is represented by capital S and it is equal to Vrms into Irms. So it is the product of Vrms into Irms. Then next is power factor. It is the ratio of real power to apparent power. So here we can write real power. What is real power? This is the real power, P, divided by apparent power. So P upon S. If we divide real power by apparent power, then we get the power factor. Also indicating the efficiency of power usage. So this power factor represents the efficiency of power usage, how much it is efficient. Now power factor is equal to cos phi, where phi is the phase angle between current and voltage. Don't forget to like, share and subscribe to this channel, and thanks for watching.